Hi everyone, welcome to chapter 2. This is a pretty short chapter and it's all about graphing. So taking descriptive statistics and representing them in graph format. You're going to actually be doing quite a bit of graphing in this class. Well, between the class and lab, you're going to have a lot of graphs to make. And that's because graphing data actually is beneficial in many ways. It really does help people to understand what your data are telling you. And so with graphs, we can present descriptive statistics visually. Most people, I think, would prefer to see a graph of your data as opposed to just a list of numbers. I know I do anyways, because with a graph, I can see patterns and trends that might not be so visible if I was just looking at a whole bunch of numbers. All right. So they say a picture's worth 1,000 words, and I think that's especially true when you're talking about statistical data. Now, there are 4 graphs that you will likely see more than any other type of graph in the behavioral sciences. And we're going to learn about these 4 graphs. Now, keep in mind that there are many other different types of graphs. I'm just going over the ones that you're most likely to encounter. So the 4 graphs are frequency histogram, frequency polygon, histogram of means, and polygon of means. Now, be very careful that you learn these names as they appear here. So in other words, don't say things like histograph instead of histogram, all right? I know histograph probably would seem like a better word for a graph, a particular type of graph, but that's not what we call it. Similarly, and I think you'll appreciate this, when we talk about, for example, a frequency polygon or polygon of means, we are talking about a polygon and not a polygraph. A polygraph is the quote-unquote lie detector, all right? And so how you say these things is very important, because just changing the word up a little bit, you might change the meaning entirely. Okay, so make sure you know these names as they appear here. Okay, now one of the things we're going to cover in this chapter is when would you choose to use a histogram and when would you choose to use a polygon. I think it's pretty obvious when you would do a frequency graph versus a graph of means. If you want to show people what the average was for each group, then you're going to plot averages, right? And if you want to show how many people were in each group, then you're going to plot frequencies. So that's kind of a no-brainer. But we do have guidelines on when you should consider using a histogram versus a polygon. But ultimately, what is most important is that you choose the graph that the readers are going to understand best. All right. So when we're communicating scientific findings, whether it's to other researchers or to the lay public, it does no good unless we can present the results in a way that everybody will understand. All right. So sometimes less is more. Right, so the first graph we're going to cover here is called a bar chart of frequencies. So it's important to tell people what you're plotting by labeling your X and Y axis. So this is your Y axis here, and by convention, we put frequency here and the different categories of the variable that you're studying on the X axis. Okay, so just remember that convention. The variable that you are studying here, the different groups, goes on the x-axis and frequency goes on the y. And then we simply create a bar to represent the number of people in this case who preferred each flavor of ice cream. And so we can see that about 5 people, right? If you line this up, 5 people preferred vanilla. And I'm guessing that this is somewhere maybe around 22, 23 preferred chocolate. What's that? Maybe 8 preferred strawberry, etc. Okay, now notice that the bars here do not touch. There's a space between them, and that is called a bar graph. Now, when would you use a bar graph? Well, by convention, if you have a nominal or an ordinal variable, then you would choose the bar graph. Now, there's no police that are going to come after you and beat down your door if, let's say, you had interval or ratio variable down here and you use this bar graph. It's just by convention that if it's nominal, in other words, these are categories that could appear in any order. For those nominal variables, we choose a bar chart. Same thing with ordinal. All right, so maybe these appear in a certain order. All right, the order makes sense. But remember that the defining characteristic of ordinal variables is that they were measured very crudely, eyeballing. Okay, and if that's the case, even though there's an order, we would still choose a bar graph. All right. Okay. Now, there's also something called a frequency histogram. So this is the bar chart, this is the histogram. So do you see the primary difference between the two? This one in the bar chart, the bars do not touch each other. There's a gap between them. But with a frequency histogram, typically the bars are right up against each other, right? So they're adjacent. And it's still the case that we're going to have frequency on the y-axis, and we are going to have, the variable that we're studying, the different categories on the x-axis. All right, but this time, if we look at the x-axis, well, definitely there's an order, right? $2, $3, $4, $5, and $6. There's an order, but not only that, this particular variable is a ratio variable, which means that you can have any amount between $2 and $3, right? Or between $2.10 and $2.05, etc. All right, so this is a continuous ratio variable. So as long as the variable down here is interval or ratio, then by convention we do a histogram where the bars actually touch one another. Then we've got a frequency polygon. And with the frequency polygon, the only difference from the histogram is that it's a line graph. We're no longer using bars or columns to represent frequency. We use a line. So this is also for interval or ratio variables. So you look down here and make sure you identify it as either interval or ratio. And then you might decide, instead of using bars, to use a line. So what you would do is you'd put a little dot here to represent whatever the frequency was for the $2 mark. And then you put a little dot here, whatever the frequency was for the $3 mark or amount. $4, okay, put a little dot here. And then you get to play a very fun game called Connect the Dots. All right. So some people prefer to see a line graph, and other people prefer to see a histogram where you have columns to represent the different frequencies. It really is a matter of personal preference. If you think this graph looks better, then I would choose this graph. If you think, the previous graph looked better, then choose that graph. All right. So again, keep in mind that ultimately the number one consideration is to use the graph that people are going to have the easiest time interpreting. Okay, so graphs, what we just looked at were graphs of frequencies, right? Where we had frequency on the y-axis. But what if you wanted to graph the mean of each group? Well, then we have a whole other set of conventions, right? So by convention, we would use a bar graph if the variable is nominal or ordinal. We would use a polygon, a line graph, if the variable is interval or ratio. and we typically never use histograms, right? And again, not like anybody's going to come after you. This is just by convention, all right? So here's a bar graph of means. Remember, it's a bar graph or a bar chart because these columns do not touch each other. And we have, here we have a nominal variable where these categories could appear in any order. It doesn't matter what order they appear in. And very important, always label your Y and X axis. Okay, so let's look at this one. This one is called the polygon of means because it's a line graph. And here, instead of doing a column where the height of the column represents the mean, right? So the mean for vanilla would be 7. The mean for chocolate would be 8, somewhere around there. Now we just put a dot where the mean should appear. So if we're looking at the caloric content in 1 scoop of ice cream and how much people like that ice cream, then here we could see, well, if the ice cream had fewer than 100 calories, the likability, the mean likability score for that ice cream wasn't very high, only about a 2. Over here, between 100 and 149 calories, well, the sweeter ice cream resulted in a higher mean score for likability. All right, and then you can see the rest of the pattern here. So it appears is that as we increase the sweetness of the ice cream, likability goes up, but if you make it too sweet, then likability begins to drop again. So this kind of illustrates what I was saying before, and that is when you have a picture to look at, you can see trends very easily. But had these numbers just been presented to you, one right after the other in text, you might not have seen the trend that you're seeing here.